So I thought I'd show a little workflow that I'm working on to use the manual S API I created. On the left here, you'll see a manual S document for a customer that I just put a system in for. And what I'll do is sort of recreate how I envision on using the API myself. So I know that a lot of you guys won't do things like this, but just for me, I'm sort of showing how hopefully it can speed up my workflow versus, filling out all of these fields. So let's see what I'm going to do. I have a little template folder I'm going to copy. Um, it's called One Way Outdoor Template. I'm going to copy it to a folder named Cram. That's my customer name. And then move into that folder. So this folder just has a couple of files that relate to inputs that I need to send to the API. So we'll go in here to the above design, which is this section in manual S here for a one-way outdoor interpolation. So change these values. I have 29,800 total and 25032 sensible. Change the CFM to 1020, and my outdoor and indoor temperatures match up because those are generally what system performance data is for systems I use. So then below design, which are these values up here, I've got a total capacity of 3,300, sensible 25,452. Got to set the CFMs the same or I get errors on the API. And once again, all the other conditions are the same. Design info, this is sort of defaults for my area, so I'm keeping all those the same. The house load, need to update, it's 47141 heating. Cooling total is 23181. Cooling sensible 20693. And then show system type, which is the same as this little drop down menu here. Also leaving the same because that's default system that I use. So now I'll make a request to the API at hvacmath.com, API version 1, interpolate, cooling, and we have a one-way outdoor interpolation. Then for the above design value, we're going to use the file above design.json. Below design, we use the below design.json file. Then we have design info.json. House load.json, and system type. So just sent a request to the server and got a response back. You could see that we're not failed. No altitude ratings were needed. The API will automatically calculate those for you if you're at a different altitude. So then, let's see, we'll compare the capacity as percent of load, which are these values down here. So they are in a different order because the API sorts all of these based off their keys. And so latent 146.6 matches up, sensible 127.6 matches, total matches 129.6. See the final capacity that it generated matches up at 30050 and 26402. It shows the sizing limits for the system type. So since we're so close on a failing on latent, let's see if I increase this we should get a failure. So we'll run that request again. Nope, that didn't fail. Let's see. Let's change below design to 28,900. So now you'll see we got a failure. I guess I do have a bug here. This should say true for is failed. But you'll see that we are actually below the latent capacity for this unit. So just showing you a little bit of a workflow that I'm going to try to work on and improve upon.